I have tried to model the famous building of the White House before. As an American representative building of the neoclassical architectural style, the White House uses many ancient Greek columns, which are called ionic columns. These columns are not placed randomly. Today, let's explore the mathematical proportional relationship between the columns. It may not necessarily be the original architect's design intention, but it is just a small study. First of all, there are two main types of columns, both called ionic columns. One is square, mainly used for exterior walls, and the other is round, mainly placed at entrances and are not connected to the wall. Next are the pillars at the parapet of the roof, those railing bottles placed in the hollowed-out part of the parapet. This time I mainly study the relationship between the ionic columns. The plane of the White House is an absolutely symmetrical rectangle. The length are expressed as L while the width are expressed as W. A semicircle protrudes from the south side, and an equilateral square protrudes from the north side. The ionic columns are not located at the four corner points, but are offset by a distance, which we represent with a lowercase letter a. Then the bounding box of the column is actually a rectangle with the length is L-2a, and the width is W-2a. Because Dynamo can be used as a parametric design tool for Revit, we can adjust the input parameters in auto mode to change the model. We can adjust the values of L, W, and A to change the appearance of the entire model to control the final purpose we want to achieve. The distance between the square columns placed along the wall should be a fixed value, which I represent here with the letter A. As you can see in the picture, the distance between the columns on the south, east, and west sides is A. This forms a certain pattern, which is also the rhythmic beauty that can be achieved by the repeated components of the building. This is also why that architecture is solidified music. We can adjust the size of this value to repeatedly adjust the most appropriate distance between columns. Secondly, there are also two ionic columns on the south entrance. Let me remind you again, the columns on the exterior wall are square columns, which is easier for construction at that time, and the ones separated from the exterior wall are rounded ionic columns. Those two ionic column is located on an arc. The distance from the center of the arc to the geometric center of the entire building is represented by the capital letter A, and the radius of the arc is represented by the letter R. Through the angle between them and the y-axis, we can control the positioning of these two ionic columns. Then let's look at the rounded ionic columns. First is the protruding entrance on the north side. This is a rectangle with four sides of equal length. The columns on the lower and upper sides are placed at equal distances, and the distance between columns on the left and the right side is not equal. It's because there's space for steps. Back to the whole model of the White House, it looks like this. The position of the columns is adjusted for the function of the steps. We can adjust the side length L of this square, the offset distance which is A here, and the number of columns on the upper and lower sides to adjust the model. This is an example of the process of the parametric design. Finally, it is the ionic column at the southern entrance, which has the same center of arc as the previous square column, but this arc is with a longer radius. The distance between them is also equally divided, so the number and position of the columns can be adjusted according to the angle. This is my simple research on the ionic column of the White House and the distances between them. The original design sheet was in imperial units, and I used metric millimeters as the modeling units, so my BIM model cannot reflect the real size of the White House. However, the relative positional relationship between these columns is the same as in the original design. There were no computers at that time, and with today's software like Revit and Dynamo, it was all done manually on paper and in the designer's head. Maybe the original design intention was not exactly the proportional relationship I found. Again, this is just in simple research. That's all for the video. Thanks for watching.